Good day, grade 10 learners. Welcome to our mathematics lesson. I am Sikulile Nguge, and this lesson is proudly brought to you by the Gauteng Department of Education. Right, I hope you are ready for our lesson, grade 10s. Please, let's make sure that we are ready. Have your book with you there. We're going to be sketching graphs. Please have your pencil and your ruler and your calculator. Okay, right, let's have our things ready, and then so that when we start, we can move together. Remember the WhatsApp line, grade 10s, 079-454-9535. Please send us your input, send us your questions. It is very, very important that you send us your questions. Please don't hesitate. If there's something you don't understand, please do send us your questions, okay? Right, I'd like us to discuss as we move, as we proceed, okay? Not to wait till the end, no. We may not have time, so during the lesson, if you've got something that you want me to re-explain, please send the question, okay? What are we going to do today, grade 10s? We're going to look at what? The exponential function. Do you remember the exponential function? We have looked at the linear function, the straight line, do you remember that? And the effect of Q on that. We looked at the parabolic function, which is the cup-shaped one, concave up, concave down. Do you remember that? We also looked at the effect of Q, vertical shift. And then the last one we did during the, what, was it last week? Last week, yes, we did the hyperbolic function, the one with the vertical asymptote and the horizontal asymptote with two arms. That's a hyperbola, isn't it? Now, today we're looking at the exponential function. Do you remember it? I'm going to give you a baseline activity on this. I want you to sketch an exponential function, okay? And then after that, I'll give you the answers. Right, so grade 10s, we're going to look at the exponential function. By the end of this lesson, we are going to be able to investigate the effect of A and Q on the graphs defined by y is equals to A times f of x plus q, where f of x is b to the power x. Now, do you remember? Exponential function, b to the power x. I've seen a lot of confusion when it comes to these ones. There's f of x is equals to x squared. This is parabolic, this is quadratic. And then f of x, or should I use g of x? G of x is equals to 2 to the power x. Do you see that they're different? This one is quadratic, this one is exponential. Do you see that the x is the exponent here? Okay, so this is exponential. G of x is exponential. F of x is quadratic. So that's what we're looking at. And we're going to see the effect of Q a lot. We're going to talk about the effect of A, but not much. But the effect of Q is the main purpose for this lesson. Right, investigate the effect of A and Q on the graphs defined by y is equal to A times f of x plus q, where f of x equals to b to the power x. But I want you to take note of these differences here. Where b is greater than 0, it means when b is positive, okay? And then when b is between 0 and 1, when b is a proper fraction like 1 over 2, 1 over 3, like that. So this is what we're going to be looking at in this lesson, okay? Right. And then we're going to sketch the graphs. And then you can refer to the CAPS document there and the examination guidelines. Right, pre-knowledge, we've done exponents, exponential functions, and exponential equations. So our knowledge about these things, we're going to use this in today's lesson. This is our baseline activity, grade 10s. I'd want you to spend a lot of time here, just sketch. That's why I'm saying sketch here, okay? But if it's giving you problems, you can just make a small table of values and then you sketch your graphs. But what I want you to do, I want you to sketch using the following. If you check here, your b, the base, is greater than 0. What did we say in the previous lesson? For this function, f of x is equals to b to the power x. If b is greater than 0, what is the shape of the graph? And then what will be the y-intercept? And where is the asymptote? I want you to use those to sketch the graphs. I'm going to give you a total of 5 minutes, okay? So meaning that 1 minute you are drawing the Cartesian plane. You don't need to draw the grid. just the x and y axis. And then after that, you can sketch your f of x, your g of x, and h of x. And then when you come back, we're going to do this together. Right, let's do it for 5 minutes. Try, please don't just wait for me. Try, even if it's wrong, it's okay. And then when I give you the solutions, you will make your corrections. Don't be afraid to try to do mathematics. We learn by trying. We learn from those mistakes that we're making. Okay? Don't just sit there and do nothing. Just try. It's okay. Right. Let's try for 5 minutes. Welcome back, grade 10s. Did you manage to sketch your graphs? I think I gave you enough time. 5 minutes was too much, okay? Right, let's do it together now. Let's start with f of x. What type of a graph is this? Because our b is 2, it is an increasing graph. And then where is the y-intercept? Remember the y-intercept? F of x is like our y, isn't it? So y is equals to 2 to the power 0, and then any base to the power 0 is 1. Let me just do all the three calculations. And then for g of x again is y is equals to 3 to the power 0, which is equal to 1. Do you see that? And then for h of x again is y is equal to 4 to the power 0, which is equal to 1. So for all these functions, the y-intercept, the coordinates of the y-intercept will be 0, 1. Do you see that? So for this basic graph, remember we said that the y-intercept, the coordinates of the y-intercept will be 0, 1. Are we going to talk about something different today? We'll find out. We'll find out if the Q is going to have an effect on this, okay? We're going to see how does the Q affect this y-intercept. Like here we can see that the three graphs, they have a common y-intercept, which is 0, 1. Do you see that? Now let's sketch our graphs. So f of x, that is f of x there, do you see? Is passing through the y-intercept 0, 1. Okay, mark that. If the shape is correct, the y-intercept is correct, and then we're going to draw let's draw the asymptote. Y is equals to 0. Okay, that is correct, okay? Right, let's go to g of x. How is g of x going to be different from f of x now? G of x, b is 3. As b increases, what happens to the graph? We talked about this in the previous lesson. It becomes steeper, isn't it? It moves towards the y-axis. It moves towards the y-axis. So g of x is going to be like this. That's the effect of when b increases. That is g of x. Do you see that? It moves towards the y-axis there. But still, the y-intercept is 0, 1. Okay? And the graph is increasing. And then h of x, because 4 is bigger, even bigger than 3. You see that? So it moves again towards the y-axis there. You see? And then that is g of x. The y-intercept is still 0, 1. Let's write this one. So f of x, the y-intercept is 0, 1. And then g of x, y-intercept 0, 1. And then h of x, y-intercept is what? 0, 1. Do you see that? So for this general equation or function, f of x is equals to b to the power x. The y-intercept will be, the coordinates of the y-intercept will be 0, 1. Do you see that? Okay. It is very, very important to understand this so that we can use it in the next part of our lesson. What about the equation of the asymptote? For all of the three, you see that they are approaching this line y is equal to 0, but they are never going to cut it. They are approaching the imaginary line y is equal to 0, but the graphs never touch the line or cut it. So the the equation of the asymptote will be y is equals to 0, y is equals to 0, y is equals to 0. Do you see that? So for this general equation, for this equation or equation in this form, the equation of the asymptote is y is equals to 0. Is q going to change this? What do you think? We'll see if q is going to change the equation of the asymptote. Right, the type of the graph, all of them increasing, okay, increasing. See that? Increasing. You see that? So if b is greater than 0, is positive, this exponential graph is increasing. Please take note of that. Let me give you just 1 minute to take your short notes, and then after this we're going to talk about the domain and range, and also after that we move on to the next part of our lesson. Okay, just take a few notes for 1 minute, and then we come back and discuss range and domain and what else. Okay, I think there's range and domain and something else that we're going to discuss. Right, just 1 minute. Well done, grade 10s. I know you're doing your work. I know you're doing your work because we see input from you, okay? We see input from you guys. Right now, remember WhatsApp line 079-454-9535. Remember that. Please send us your questions. If there's something you want me to explain that you have missed, please do so. Send your questions. Right, let's discuss the other key features. The domain, the range, and the x-intercept, okay? Right, we talked about the y-intercept in the previous one. Right, the domain. Do you remember the domain for this function? Do you remember it? Is it similar to the quadratic function? Yes, it is, because x is an element of real numbers. So we're saying that all the x values from negative infinity to infinity, we can put any value. Remember, the domain is the input values, which are the x values, which are the input values are what? The independent variables. Do you remember that when you started the function concept? Yes. And then someone asked me, say, what does infinity mean? It means it's going to the negative, it does not end, and then also going to the positive is not ending. You see that? Okay, so the x, I'll use one notation. Remember, there are different notations that we can use. Right, I'll say x element of real numbers. No restriction there. Okay, x element of real numbers. Okay, the one with restriction, remember, is the the hyperbola, which is restrictions where they are asymptotes there. Remember that. And then x element of real numbers, no restriction, from negative infinity to infinity. X element of real numbers, no restriction. Right, you see that? From negative infinity to infinity. Right, what about the range? Where is the graph? Remember, the asymptote is here. And then is y is equals to 0. So the range is the y values. Where are the graphs? Is it y greater than 0 or y less than 0? The graphs are above the x-axis. Remember, above the x-axis, we are saying y greater than 0, because above the x-axis, y is greater than 0. And then below the x-axis, y is less than 0. Do you know that? So you can see our graphs here. They are above the x-axis. So y is greater than 0. Y is greater than 0. Do you remember the parabolic one? When it's concave half, we say y greater than or equals to, because 0 is included. But here we cannot include the asymptote. We cannot include the asymptote because the graph will not touch the asymptote. So it's greater than without the equal thing. Okay, it's greater than, not included. 0 is not included. And then for g of x, again, y is greater than 0. For h of x, y is greater than 0. Is this range going to be affected by q? We have to find out, because we haven't talked about the effect of q yet. Okay, we'll see now. We want to see if this range is going to be affected by the q. Okay, right. And then x-intercept. Do you see anywhere where the graph cuts the x-axis? The three of them? No way, isn't it? So they are not cutting the x-axis, so there's no x-intercept. So there's none here, none, or no x-intercept. No x-intercept. No x-intercept. Okay, right. We have done our baseline, and I really hope that this part of the lesson that we have done will assist us a lot in understanding the effect of Q. Now we're going to move on and start looking at the effect of Q. Okay, right. If there are any questions, please send the questions to 079-454-9535. Okay, right. Let's move on. On the same set of x's, plot the graphs of f of x is equals to 2 to the power x, and then g of x 2 to the power x plus 1, then h of x 2 to the power x minus 2. Now we are looking at the function f of x is equals to b to the power x. Let me just include the a here, and then plus q. Okay, want to see the effect of q. What is q here? It is 1. What is q here? Is negative 2. What is q here for f of x? Anyone who can say that? You can say it in the classroom there. What is q for f of x? It is 0, isn't it? You see that? It is 0. So now I'm going to give you the table of values, and then we sketch our graphs. Okay, let's use this table of values. Okay, So I'm going to give you time to sketch, to draw the Cartesian plane. Then we come back to this table so that you can then what? You can then sketch your graphs, okay? All right, let's go to the Cartesian plane. And then I'm going to give you 1 minute to draw the Cartesian plane. If you can see this table, it's fine. You can continue with it. But after 1 minute, I'll go back to the bigger table so that you can what? Maybe some people cannot see this small text there. Maybe some people may not see. So 1 minute to draw the Cartesian plane. Don't worry about the grid. Just draw your vertical axis and the horizontal axis, x and y axis. Then it's fine. Then we go to the table and sketch the graphs. Let's do that for 1 minute. Right, well done. I hope you have your Cartesian plane now. And if you are still drawing it, continue and then you can finish. Just know that for your x-axis can start from -3 to 3. And then for your y-axis can start from -2 up to 4. Okay, right. Let me just show you the bigger table and then you start sketching your graphs. Okay, right. Let's go back to the bigger table. Right, let's draw f of x. Let's start with f of x. Remember how you get the coordinates for f of x. This is your x, this is your y. X, y, x, y, x, y, x, y. Let's plot f of x. I'm going to give you 2 minutes to sketch your f of x. Let's try. Right, welcome back, cretins. Did you manage to sketch the graph? Let's see what you managed to do. Right, this is how you're supposed to sketch your f of x. -2 is 1/4. 1/4 as a decimal, because sometimes to sketch a fraction is difficult, isn't it? So what you do, just go to your calculator, 1 divided by 4. What do you get? and then 0.25. Do you see that? So we know 0.25 should be somewhere here, because this is 0.5. 0.25 is half of 0.5, so it's somewhere there. And then -1 goes with 0.5. You do the same thing. 1/2 is 0.5. So convert your fraction to a decimal to see where to plot. So 0.5 is here between 0 and 1. And then 0 goes with 1. And then 1 goes with 2. And then 2 goes with 4. Okay, so that is the problem. Maybe the problem was where we're supposed to sketch what the 1/4 and 1/2 there. Okay, those decimals, convert them to decimals so that it's easy for you to see where to plot. And then we sketch our f of x, which is that. Now you see this graph is approaching which line? When going this way, it's approaching which line? Is approaching y is equals to 0. That's our asymptote. Y is equals to 0 is the asymptote, because this graph is approaching that line. Okay, now sketch back corrections. For f of x, it should be like this, and then also write the equation of the asymptote on top of your asymptote there, so that you can easily see when you are comparing these three graphs. Let's do that for 1 minute. Right, welcome back, Cretans. Did you make corrections? Right, I'm thinking now, let's do this. I'm going to sketch the graphs for h of x and g of x, and then I'll give you time to copy them, okay, so that we don't lose a lot of time. Right, now remember the WhatsApp line 079-454-9535. Right, let's start with g of x. Right, when is -2, 5/4 should be 1,25. Where is 1,25? 1,25 should be here. Okay, and then when x is -1, this should be 3/2 is 1,5 as a decimal. 1,5 should be here. And then 0 goes with 2, so it is here. 0 goes with 2. And then 1 goes with 3, it is here. Am I right? Yes. Okay, and then 2 goes with 5, so 5 should be up there, somewhere there. Okay, and then we can sketch our graph for g of x, which is this. You see that? Now, where is the asymptote? Which line is being approached here? Okay, you can even try to put this in the calculator. Let's say if x is -10, let's say 2 to the power -10, 2 to the power -10, and then plus 1 is like 1,00097 something. And then I can even put this. I've done this one for you. Let's put -20 and see what we're getting. You see, 1,0000. So which line is being approached here? If you check, it is y is equals to 1 is being approached. So that's the asymptote. Y is equals to 1. Please, well, I'm going to give you time to sketch the three graphs. Let's just go to g of x, and then after that I'll give you time to sketch the three. Okay, and then g of x, -2 goes with -7/4. What is -7/4? 7/4. 7 divided by 4 is a fraction, 1,75. So 1,75 should be somewhere here. And then -1,5. 3/2 is 1,5, so it should be here. And then 0 goes with -1. And then 1 goes with 0 is here. Then 2 goes with 2, so it's here. There, you see that? And then we sketch this. Okay, you see that? And then which line is being approached here? If you check here, okay, I just put negative. If x is negative 20, very negative number, right? We see in negative 1,99999, which line is being approached here? Is y is equals to negative 2, right? I want you to sketch the graphs. Please don't forget to sketch what? Even the asymptotes and the intercepts, x and y intercepts, they must be accurate. I'm going to give you 2 minutes to sketch the graphs, and then after that, we're going to discuss the key features. Let's do that. Right, welcome back, returns. Welcome back. Let's look at the key features now of our 3 graphs. The y-intercept, the equation of the asymptote, and the type of graph. The type of graph here, I want you to say if it's what is increasing or decreasing. Okay, right, but I want you to discuss this before I give you answers. Okay, I want you to discuss this. You understand better sometimes. Do you know that sometimes you learn from each other? Okay, the information is not coming just straight from me every time. Also, let's try to learn from each other. Right, let me give you just 1 minute to discuss the key features there. What do you see when you look at the y-intercept, and then the equation of the asymptote, and then the type of the graph, and try to look at these equations also, and try to link these things with the equation and see if you can come up with something. Anything is an open-ended question. Please, let's try to discuss. You know now the rules for discussions, isn't it? Don't make noise, don't disturb anyone. We need every second. Right now, let's discuss for 1 minute. Right, welcome back. Great turns. I really hope you managed to discuss and you managed to learn something from each other. Okay, right, let's discuss. So the red graph is our parent graph. That's where these other two graphs are coming from. Right, f of x, let me just write the q value for f of x here is like plus 0. Okay, right, now let's look at the y-intercepts. For f of x is still the 0, 1. We discussed about, remember we talked about this when we were doing the baseline activity. Right, what about g of x? It is here. What are the coordinates there? 0, 2, 0, 2. Okay. Right. And then let's look at h of x. It is here. It is 0, negative 1. How can we link these coordinates of the y-intercept to our q values? How can we do that? Can we generalize that? Yes, we can. I am observing something here. To find the coordinates of the y-intercept for this function, f of x is equal to b to the power x plus q. We can say the coordinates of the y-intercept are 0, 1 plus q. Okay, do you see that? If our q was 1, we said 1 plus 1, we got 2. And then if our q was negative 2, we said 1 minus 2, we got what? We got negative 1. You see that? So we can generalize and say it is 0 and then 1 plus q for what? For the y-intercept, the coordinates of the y-intercept. Okay? What about the equation of the asymptotes? Our parent graph, the red graph, y is equals to 0. What about the equation of the asymptote for the blue graph, g of x? Y is equals to 1. And then what about the green graph, h of x? Y is equals to negative 2. What can you say? How can we link the equation of the asymptote with the q value? We can say here, y is equals to q. The equation of the asymptote is y is equals to q. Do you see that? Okay, right. You can write your short notes as we proceed. Right, the type of the graph, because b is greater than 0, remember that we say it is increasing. Increasing means that as x values increase, the y values also increase. Okay, just know that if the gradient is going up like that, okay, it's an increasing graph. When it's going down like this, it's a decreasing graph. Okay, and then increasing, and then increasing. Okay, right. Those are the key features, some of the key features for these three graphs. We have seen here the effect of Q, especially on the y-intercept and the equations of the asymptotes. Okay, now, okay, I wanted to give you some questions there. Let's leave it. Right, now let's talk about the domain. The domain is the same. The domain is the same. So it's, okay, remember when you talked about the baseline, we say the domain from negative infinity to infinity. That's the domain. But is the range going to be the same here? You see, the blue graph went up from red to blue, shifted upwards. And then from red to green, it shifted downwards. So the ranges there are no longer the same, but the domains is still the same. So if you check, the Q does not affect the domain. If you check for the linear graph, for the parabolic function, for the hyperbolic function, even for the exponential function, the Q value does not affect the domain. It affects what? The range. Okay, so the domain, x element of real numbers, x element of real numbers, x element of real numbers. But what the domain, not the range, domain. And then the range, we say this one, the range is y greater than 0 because the asymptote cannot be included. It's not included. What about the g of x, the blue graph? What's the range? Raise your hand and say your answer. What's the range for the blue graph? Y is greater than 1. Y is greater than 1 because the graph is above the line y is equal to 1 there. So y is greater than 1. Remember here, we said plus 0. And then for the green graph, what's the range? Y greater than negative 2. y greater than negative 2, learners. Right, you see that? Can we link this range to the Q value? Yes, we can. You see? For the red graph, y greater than 0. For the blue graph, y greater than 1. For the green graph, y greater than negative 2. So we can generalize our range and say our range is y greater than q. Okay, if I give you any equation, I can give you this equation and say f of x is equals to, let me say 5 to the power x plus 6. I can ask you this question from here. In fact, can you answer this? You can raise your hand and give the answers. I will say, what is the equation of, let me call it kx, because we have f of x. What is the equation of the asymptote for k of x? What is the equation of the asymptote for k of x? Y is equals to? Y is equals to 6. Okay? What is the range for k of x? Y is greater than 6. What else? What is the y? What are the coordinates of the y-intercept for k of x? 0, and then 1 plus 6, which is 7. So it's going to be 0, 7. Do you see that? So now, from our generalization, we can just get these key features from the equation. You see that? Okay? Right. Okay? And then the x-intercepts, the blue graph does not cut the x-axis, so there's no x-intercept there. And then the red graph does not cut the x-axis, there's no x-intercept there. And then the green graph cuts the x-axis here at 1. So the coordinates there are 1, 0. Okay, you can even calculate these coordinates or determine these coordinates using what? Algebra. Do you know that? Right. X-intercept, y is equals to 0. So where there's, remember this is y is equal to 2x minus 2. And then where there's y, we put 0 to find the x-intercept. So 0 is equal to 2 to the power x minus 2. We transpose the 2 to the left-hand side. Negative 2 becomes positive 2. So it's 2 is equals to 2 to the power x. Then 2 is like 2 to the power 1. And then if the bases are equal, then we can equate the exponents. Becomes 1 is equals to x. You see that? And then this point here is 1, 0. You see that? Okay. Right. So now we want to look at a situation now where b is between 0 and 1. B is between 0 and 1. And because of time, I'm going to, or let me do this. Let me give you 1 minute to copy the corrections. I didn't give you time to do that, okay? And then after that, I'm going to sketch this graph for you, and then you copy them. Right, let's go back a bit, and then you just write your short notes for 1 minute. Very simple. Right, welcome back, grade 10s. There's a question about the gradient of the y-axis. I'm not sure if it is clear. Please, you can try to paraphrase it. Try to paraphrase your question so that I can answer you. But the gradient of the y-axis is undefined. Remember that. And then the gradient of a horizontal line or horizontal axis, the axis is 0, isn't it? The gradient of a vertical line is undefined. The gradient of the horizontal line is 0. But now try to paraphrase your question. I may not be answering what you wanted to ask, but try to put it in other words. Okay? Then we'll try to assist you. Right. And then now, like I said, let's sketch these three graphs, then we discuss, because we're left with about 15 minutes. And then now we have these three functions. Please write the equations down. F of x is equals to half to the power x. G of x is equals to half to the power x plus 2. And then h of x is equals to half to the power x minus 1. Okay, how is it going to be different from the previous one now? If you check our b is now what? Our b is now between 0 and 1. Okay, the previous one, our b, the basis was 2, so it must, the previous one, our b was greater than 0. But now our b is between 0 and 1. So we want to see the effect of that, and also the effect of the q's there. Is it going to be the same? We're going to find out. So now let me explain as I sketch the graphs. Then I'll give you 2 minutes to copy the three graphs. Then we discuss the key features. Then we'll be done. Okay. Right now, this is how we're going to sketch the coordinates. We've been doing this. I'm going to pick this x, y, x, y, x, y, x, y like this, and then we sketch the graph. So f of x is going to be like this. If you check, it's now different. Do you see that? It's actually the reflection here about the y-axis, but we're not going to concentrate on that today. It's another lesson on reflections, right? Okay, so the graph is going to be like that with the asymptote there. Okay, y is equal to 0. Okay, right, just wait, and then I'm going to sketch for you. Now, G, I'm going to give you time to sketch. And then for G, we're picking these points for x and y. Okay, and then if you sketch G of x is going to be like this. And then if you check the line is approaching 2 there, it means our asymptote is y is equals to 2. You see that? Okay, right. And then h of x, we're picking this one and this one, this one and this one, this one and this one, this one. Remember, from the table to ordered pairs. We did all these lessons, okay? These representations, right, from table to ordered pairs. And then we can sketch our graphs like this. The line which is being approached here is -1. We can see that. And then our equation is y is equal to -1. Let's have 2 minutes to copy this graph. Please take note. The shape must be correct. The y-intercept must be correct. The x-intercept must be correct if it is there. And then the equations of the asymptotes also must be correct, so that when we're discussing, we know we're discussing the right things. Let's copy the graphs for 2 minutes. Welcome back, grade 10s. Did you manage to copy the graphs? I hope so. Right, what's the next thing I want you to discuss? I'm going to give you 2 minutes, okay? Right, these are the things I want you to talk about. Right, where are they? Okay, my pen is not moving. Okay, perfect. Right, I want you to discuss about the y-intercept, the equation of the asymptote, and the type of the graph. Is it increasing or decreasing? Okay, and then on top of these, I want you to discuss about the domain and range. Okay, and then when I come back after 2 minutes, we're going to discuss all these concepts, and then I give you the homework, and then there's a short activity that we're going to do. We'll do it fast together, and then I give you the homework, then we summarize, then we're done. So now can you discuss this, including the domain and range, just for 2 minutes, and then after 2 minutes I come back, then we try to finish our lesson. Let's do it. Right, welcome back, learners. I really hope you managed to do something. Let's talk about the y-intercept for our parent graph, f of x. The y-intercept is 0, 1. And then for g of x, we said that in the previous part of our lesson, we said that it's going to be 0 and then 1 plus q. Is it the case in this one? Yes, it is, because our q is 2, so it's going to be 1 plus 2, which is 3. Yes, we can see it is at 0, 3 there. You see that? So it's 0, 3. And then our q is negative 1 here. So if you say 0 and then 1 minus, or you can say plus, negative 1 is still fine, which is the same as 1 minus 1, which is 0, 0. Do you see that? Is it at 0, 0 at the origin? Yes, it is 0, 0. Do you see that? So we can generalize just like in the previous part of our lesson. Okay, we can say that the y-intercept will be 0 for the x coordinate, and then 1 plus q for the what? For the y coordinate of the y-intercept. So here is 0, 0. And then the equation of the asymptote, our q here is 0. So can you say y is equal to 0? Yes, it is there. So y is equal to 0. Our q is positive 2 here. So is it y is equal to 2? Yes. You see that? Y is equal to 2. And then it's negative 1 here. So is our equation of the asymptote y is equal to negative 1? Yes, we can see that. So it's y is equal to negative 1. Do you see that? Okay. And then our b is between 0 and 1. Okay, 0 not included, 1 not included. So we can see that it is a decreasing graph. So the graph is decreasing, decreasing, and then decreasing. Okay, right. Right, you managed to discuss this before me, so now it's fine. We can move on to the next part, the domain and range. Right, the domain, does it change? No. X element of real numbers. We can say X from negative infinity to infinity is still okay. X element of real numbers, X element of real numbers. The range, we said from our previous part of the lesson, we said our range will be Y greater than Q. Is it the same thing here? Yes, it is. So it's going to be Y greater than 0. Okay, Q is 0 here, Y greater than 0. And then Q is 2 here, so it's going to be Y greater than 2. And then Q is negative 1 here, so it's Y greater than negative 1. Please take note. I'm not saying that all the exponential functions, it will be like this, because we haven't done the reflection about the x-axis, which is totally different. Okay, let's say if our graph is like this, it is like this. You see that the range is going to be different here because the graph I've drawn here is actually, the range is y less than 0. Okay, but we cannot do this in one lesson, so that's why we just concentrated on what, on these ones where the range is above the x-axis, okay, or above the asymptote in this case. Okay, all right, but we can have another lesson later for this other reflection. Right, and then the x-intercept, yes, this one has the x-intercept, but the other two, none. For a red graph, none. For blue graph, none. And then for the green graph, it is 0, 0. And then we can also find our x-intercept or y-intercept using algebra here, because it's y is equals to half to the power x minus 1. And then we said y-intercept is when x-intercept is when y is equal to 0. So we say 0 is equals to half minus 1. And then bring 1 this side. 1 is equals to half to the power x. Then how do we solve this? 1 is equals to half to the power x. And then remember, any base raised to the power of 0 is 1. So this is like half to the power of 0 is equals to half to the power of x. Therefore, x is equals to 0. Do you see that? Okay, you can do that. Now, this is a short activity. I'm going to do it with you, but if you can do it fast, let's do it. Just the asymptote, the shape, and what? The y-intercept will give you your graph. Let's do it, okay? But let's just, from this, what do we see? This is our Q value. What can you say? What is our asymptote? Y is equal to negative 1. So draw your asymptote at y is equal to negative 1. Right, okay. Right, where is the y-intercept? It's going to be 0, and then 1 plus q. And then our q here is negative 1, so it's going to be 0, 1 minus 1, so meaning that is 0, 0. Okay, so that is our y-intercept there, 0, 0. Do you see that? And then b is between 0 and 1. It's a proper fraction, so it means our graph is decreasing. So our graph is decreasing. Then we've just sketched the graph. Done. You see that? So you can use these parameters just to sketch your graph without using the table of values. Okay? Right. Now, and then this is your homework. What I want you to do, don't copy the whole thing. We are left with 0 minutes. So just f of x, g of x, and then h of x. And then you talk about, is it a decreasing or increasing function, domain, range, asymptote, x-intercept, y-intercept. What the things that we have been discussing. Just write the 3 questions just for 1 minute. And then we summarize our lesson. 1 minute. Welcome back, cretins. Please try to do this. We didn't manage to do this part, so because of time, but now check your a is negative now. Remember, a, we're saying f of x is equals to a times b to the power x plus q. So our a is negative now. What will happen? It means your graphs are going to be below the asymptotes now. Your graphs are going to be below the asymptotes, okay? Right, try to sketch those ones. If it's giving problems, just create a small table of values, maybe from -2 to 2, and then you sketch them. It's okay. And then you'll see what I'm talking about, okay? Right. Now, we say the domain is for f of x equals to b to the power x plus q. We say that domain, x element of real numbers, and then we say that, or we can even write it like this, okay? And then what we say about the range, we said y is greater than q. You can even write it like this. You see, not included. The round bracket means not included. When it's included, we use the square bracket, okay? Right. And then the equation of the horizontal asymptote, we said y is equals to q. And then the graph is an increasing function if b is greater than 0. That's what we talked about. You should be having these in your notes, so don't stress, okay? We're just summarizing. And then we also talked about this situation when b is between 0 and 1. We say that domain x element of real numbers, you can also represent it like this. You can say y is greater than q. For the range, you can also represent it like this. And then the equation of the horizontal asymptote is still the same. Y is equals to q. And then the graph is decreasing function. So now when the graphs are reflected on the x-axis, you see that the range, especially the range, is one which is going to change and become like y is less than q. Okay, please take note of that. And I really hope that you learned something from this lesson and we'll continue going to learn. And then we are meeting next week for our other lesson. Let's meet next week. Greetings. Goodbye.